thought we left off. We finished up 5.4. 5.4, when you finish 5.4, it was specifically associated with putting your data inside of Zuru and coming up with an exponential or log equation. That's where we left with 5.4. So we should be starting 5.5. So we'll finish 5.5 and 6, and then we'll talk about the study guide. So with that said, let's take a look at this next topic. It only got 3 slides. So we're going to finish this in like a couple of minutes. So it's only got 3 slides. This last part literally talks about money. Now, when I say we're talking about money, we want to talk about, do you want your money to grow or stay the same? Grow. So this whole next section is talking about what has to happen in order for your money to grow over a period of time. So with that said, here's the first slide. Do not write down the first formula because this next 2 take care of that one. So don't write down the first formula you see in bullet number 2. Write down the next 2. So this is about the future value of money that you invest. It could be invested in a savings account that you get interest on. It could be in a CD. It could be in a mutual fund. It could be in whatever kind of investment you put it in. You could have put it in your mama's hand, and she said she'll invest it for you and get you some money back over a period of time, whatever the interest rate is. So we're going to talk about how your money grows over time. So the second bullet just tells you that, hey, this is how much money you're going to have if your money grows and it's compounded annually. Don't focus on that one. Focus on the next 2 bullets. The bullet 3 and 4 are the important ones that I want to focus on. It says if the interest is compounded periodically over a period of time, your money should grow to look like what you see on the screen. Here's the formula that you have. S. And let me write this on the board while I'm talking. The formula is, the S is equal to, P times, you've got a parentheses, 1 plus R divided by K, all of that raised to the K times T power. All right, so let me tell you what each one of the letters represents. This is the amount that you have after your money has grown. So this is the sum total of the amount that you have after your money has been sitting in an account somewhere growing over a period of time at a certain percentage rate. P is the principal amount of money that you put into that account, the principal amount in the account. R is your interest rate. All right, K is time in years. Excuse me, T is time in years. I'm sorry. T is time in years. K happens to be the compounding rate. How often the money is being compounded. We're going to call it the compounding rate. I know it's got a K and I'm calling it compound rate, but that's what it is. It's a compounding rate. How often is it being compounded? So in each of these cases, you literally just gonna plug numbers in for P, R, K, and T, put it in your calculator. That's it. So we're gonna do the same thing with the second, not the second, but the last bullet as well. There's a difference between those 2 equations. This one has a K. That one doesn't have a K. So over here, we call the K the compounding rate. Now, compounding means, again, how often something's being multiplied over and over and over again so that you keep adding money to your money, right? So the first one happens to be, it's going to say something like, it was compounding annually. Well, how many times, if you pay something annually or someone gives you something annually, how often is that going to happen? Once a year. So annually means 1 time a year. So that's equal to 1. So K is equal to 1 for annually. What's the next one you think I could use for periodically when something's being compounded? Quarterly. What's before quarterly? Monthly. Y'all going down. Let's go back.
Monthly,
Semi-annually.
Oh.
How many times if something happens or somebody gives you money semi-annually, how many times are they gonna give it to you? Twice a year. Okay, 2 times. Then we can go to quarterly. How many times is quarterly? 4. So quarterly is equal to 4 times. And what's after quarterly? Y'all said it already? Monthly. Okay. Which is how many times per year? 12. Where can I go after that? Can we do bi-weekly? We could do bi-monthly, bi-weekly. We're going to do bi-weekly with this one. Some people get paid bi-monthly. We're just going to say bi-weekly. 26. What would bi-monthly be? It would be 24. So if we put down bi-monthly, will equal 24. What's underneath there? Weekly. And how many times would that be in a year? 50 what? 52? Okay. And the last one would be daily. Okay. So, every time in the homework when it says something is compounding annually, it's not going to, usually it won't tell you the number. It's expecting you to know if I say semi-annually, K is 2. If I say quarterly, they're expecting us to know K is 4. And daily, K is 365. So they want us to already know what each one of these terms mean. You okay with that? Alrighty, so we're going to plug in K for whatever they tell us that it represents. And it's going to tell us what the interest rate is. It might say 5%, 6%, 10%, whatever it says, we're going to plug it in. And it's going to give us the time in years, which it might be 3 years, 2 years, 15 years. And we're going to plug in each one of those variables. It's going to tell you what the initial amount is that you have to invest. And you just literally plug it into the calculator. Well, let's look at the last bullet. Now, the last equation, I call it the PERT equation because it's P times E raised to the R times T. Now, this is used when it says your money is compounding continuously all the time, 24/7. Compounding continuously, you have to use this equation. This one will say periodic compounding. So you got your periodic times of year that it's going to compound. This one will say compounds all day, every minute of the day, every second. This is compounding continuously. Okay? And so again, and this is, okay? So now we'll use the E. It's got an E button on your calculator, so you're going to use your E button. It's going to give us the rate, and it's going to give us the time in years. And we just plug the numbers in. Your calculator, we get an answer. We're good? Okay? The next one, or the last slide for this one, is your lump sum formula. So this one is called your lump sum formula because you've got to figure out how much of a lump sum of money you're going to need. This is called the lump sum formula, and literally in most of them it'll say lump sum, so you know that's the formula you have to use. Alrighty, so on your slide that you have, it may not have said that because I changed it, had different letters of the alphabet. So you can see the lump sum formula looks like this that you see on the screen. S over 1 plus R over K, all of that raised to the KT power. Now, what's the difference between this formula and this one? Look at right here. What's the difference between these two?
It's reversed, huh?
It looks like it's kind of reversed. One is divided by all. So all of this went to the bottom. So it's just basically got a division sign. And can you see that the P and the S switch places? So they're similar equations. So if you get one of them, the goal is that you can figure out what the other one is. Lump sum will always have the division. The lump sum will always have the division in it. You got it? So are we just going to plug numbers in? Yes, we are. Well, let's talk about the lump sum formula for a second. This says, let's say you want to buy a car in 5 years, and the car is going to be $10,000. How much money do you need to have right now? So in 10 years, you will have saved up enough money, and when I say save, I mean you would have put it in an account somewhere so it's saved and getting interest on it. How much money do you need to have right now so that you can have $10,000 in, how many years did I say? 5 years. So in 5 years, I want to have $10,000. How much I'm going to need to put in the bank today? That's what this formula does. So how much money do you want to have in 5 years?
10,000.
That goes right here. That's the sum of money that you want to have in 5 years. So if you want to have $10,000, you put $10,000 right here. You take it to the bank. Excuse me, you take the amount of money you got to the bank. You don't know how much you need yet. The question, what this answers is, how much money do you take to the bank? That's what this P is. How much is the principal amount of money that you need to take to the bank so you can have this much in 5 years? So you're going to plug 10,000 here. Your rate, the bank will tell you what the interest rate's going to be. It'll tell you how often it's going to get compounded. And once we plug all of this into the formula, it'll tell us how much money I need to have today. So let's do that one just so you will see what this works out to be. All right, I want to know if I need $10,000 in 5 years. The bank told me my interest rate is going to be about 3%. I'm going to write that as 0.03. I need 5 years. And it's going to be raised to the 5 times. And I didn't say something. What did I not tell you? I didn't tell you how often it was compounded, so I wrote the wrong number on the bottom there. It's compounding monthly. 12. Okay, so K equals 12, and you end up with a 12 here. And let me put the 12 first. 12 times 5. Alrighty, I need $10,000 in 5 years. The bank told me my interest rate is going to be 3%. They said they're going to compound it monthly, and we're going to do this for 5 years. How much money do I need to have today to go put in the bank? That's what this is going to tell us. Somebody put this in the calculator. Now the key is how you put it in the calculator. If you have the fraction box, how many of you have fraction boxes on your calculator? Write the box right. If you have a fraction box on your, when I say this, do you have this button on your calculator? Yes. If you do, put it in there like that. Put this, hit the fraction box, put the 10,000 on top, and put everything you see in parentheses on the bottom. Now, if you don't have the fraction box, then you literally can still type it, but you're going to have to hit, when you get to this part, you need to either use the slash or the division sign. How many of you have the division? How many of you had a fraction box? How many don't have a fraction box? All right, so here's how you got to type this in if you don't have a fraction box. You actually have to write 10,000 slash or division sign, whichever one you can put the division symbol here. Parentheses 1 plus 0.03 divided by 12. I'm just telling you what to type in so you'll know what it should look like. Some of you, your calculator will show it to you just like this when you type it. I don't know who's got what calculator that lets you see it like that. So if this is divided by 12, parentheses, raised to the power of, whatever your raised to the power of little doohickey thing is, and then that's going to be 12 times 5, which you know is 60. So if you don't have the button that lets you put it in fraction form, can you put it in fraction form? It's best if you do it this way. If you don't, type it all in there like that. I'm trying to make sure I said everything right with that one. Okay. I need to know the answer.
I've got an 8608.69.
Point what?
69.
Okay, do you all agree?
Yeah.
Okay, so in order to have $10,000 in 5 years, given they only gonna give you 3% interest on it, You gotta go to the bank with how much money today? There you go. You'll make a couple $1,000, not even a couple $1,000. You know, so then this how much money you need to have right now to go to the bank to have 10,000 in 5 years. So you got what we're doing? What kind of problem was this called? Lump sum. It will say lump sum in the question. That's how you know you need to use this particular problem, this particular form. It will say lump sum. All right, questions? You're good? All right, that is the end of chapter 5. So can you see chapter 5 is literally you just plugging the right numbers into your calculator? As long as you put them in your calculator right, you're good. Okay? I'm going to come back to the practice problems for these that's on the study guide. So I want to do the ones from the study guide that's like these. Alrighty, so now I'm going to chapter 6 and then I'm going to jump straight to the study guide. Here is chapter 6. There's only 8 slides in chapter 6 and 2 of them are just your outline topic slides. So we've only got 6 slides to cover. Alrighty, so chapter 6 is going to be talking about higher degree polynomials. Alright, higher degree means the exponent is bigger than a 2. If your exponent is larger than 2, it's considered a higher degree polynomial. And the only ones that we're going to focus on, let me push this board up and pull this one down. The only 2 that we're going to focus on are these 2. One's called cubic, and it's y equals x to the 3rd is the simplest one that you can have. And we're going to talk about ones that are called quartic, which is y equals x to the 4th. Those are the only 2 higher degrees we're going to do. We're not going to do x to the 5th power, x to the 6th power. We're only doing them if their highest exponent is a 3 or 4. Okay?
And do we put these in 0?
We will. I will show you where.
Okay, because, yeah, I couldn't figure that
It's under PR.
out.
Okay, so under there, under this conversation, we have to talk about extreme points. Now, when they say extreme points, they just mean peaks and valleys. Do you know what peaks and valleys are? Mountaintops and bottoms. So if I draw the curve of this one, here's just a basic curve of this one. Here's a curve of this one. Do they have some peaks and valleys? Yes. Those peaks and valleys are called turning points. They could cross the x-axis. They could touch. So bullet number 2 says it could cross the x-axis and you could have something called x-intercepts. Okay? How many times can it cross the x-axis? Well, it depends on the degree. If n is 3, they're calling n the degree, which is the 3. The degree is the highest exponent that you see. In this one, what's the highest exponent?
3.
So what's the degree?
3.
Okay, so this has a degree of 3. So in this case, they're saying n is equal to 3. They're calling n the degree. Over here for the quartic one, what's the degree? 4. So the degree equals 4. So it says if the degree is 4, how many x-intercepts can it have? Look up there what it says. If the degree is n, then it has at most n x-intercepts. So if it's 4 degree, what's the highest number of x-intercepts it could have? 4. If the degree is 3, what's the highest number of x-intercepts it could have? 3. That's the highest. At most means the highest. Does it have to have 3? No. Does the other one have to have 4? No. It's just saying that's the most it could have. X-intercepts is where it crosses the what? Where it crosses the x-axis. So it could cross the x-axis up to 3 times for the cubic function, and it could cross the x-axis up to 4 times for the quartic function. That's all that they're asking there. How many could it do? Yes.
What does the n represent again?
The degree.
Okay, just the degree.
I was just showing you that in the slide it used n for the degree.
Okay.
All right, so with that said, here are the extreme points that we're going to talk about. The extreme points are the peaks and valleys or the turning points. Your extreme points are considered peaks and valleys or your turning point. Call them peaks and valleys. Valleys. What's the plural for valleys? For some reason I see it, I think I spelled that wrong. Okay. Tops and bottoms. Alrighty, so extreme points are tops and bottoms, or we can call them turning points. Do you see some turning points here? How many? Two turning points, or if it's going up, it's got to turn around and come back down. If it's going down, it's got to turn around and come back up. So these are called your turning points. Here's one here, and here's one here. I'm going to erase the shape of this one just a teeny tiny bit because I want to make a point with this one. So I'm going to change my shape just a little bit. Okay, so extreme points are tops and bottoms or peaks and valleys, or we call them turning points. In the homework, it may say turning points. It's not going to say peaks and valleys. It's going to call them turning points or extreme points. So here are my turning points here. Alrighty? We call these also, what other word do you see up there that we call them? Maximum and minimum. So this one should be what? What should I call this one? A maximum or a minimum? Minimum. What should I call this one up top? Maximum. Okay. You okay with that? These turning points are called minimums and maximums. Alrighty, so now look at this quartic one. Does it have some turning points? Yes. How many? Three turning points here, here, and here. Interesting. Can I label them maxes and mins? Yes. Okay. What's this one up top up here? This one's called the maximum. Alrighty. What about these two? They're both minimums, but there's another word on the slide. They got absolute and they got local. If there's one maximum, one minimum, they're local. If you happen to have two of them, one is the absolute low, or one is the absolute maximum. So this one's a minimum and this is a minimum. Which one is the absolute? The lowest one is the absolute. This one's going to be called the absolute lowest. So it's the absolute minimum. Absolute. Ready? If I rewrite this and call this equation y equals x to the negative 4 power, here's what my shape might look like. So for x to the 4th power, it might look like a W or an M. Do I still have turning points? Yes, I do. Here's a point here, here's a point here, and here's a point here. In this particular case, can I label my turning points as maxes and mins?
Yes.
All right, where my maxes at?
At the top.
Okay, so I've got a maximum here, and I've got a maximum here. Whoops, that's not max. A maximum there. What's this one called down here?
Minimum.
That's a minimum. Now, which one is this one going to call? It has a specific name.
Absolute.
It's the absolute maximum because it's the highest point of the curve. All right, so this is the absolute maximum here. You're good? Did you notice that the negative sign caused that curve to flip upside down? Remember, negative sign does this, so I just flipped it upside down. Alrighty, let me write one over here. What happens if I flip this one upside down?
Same thing. I mean, this will be 2 points.
Still gonna have 2 points, right? Where's the max and min?
The minimum is at the bottom.
Minimum is at the bottom, maximum is at the top. So here's my max, and here's my min. You okay? So far, so good? Okay. Alrighty, so we've talked about everything on that slide. Here is the next slide. So, a 3rd degree polynomial, the highest exponent has to be a what? 3. A 3, and it's called a cubic function The basic one or the simplest one is the one that I put up here at the top of the board. That's the easiest one you can see is y equals x to the third. Can I create one that's a little bit more complicated? Sure I can. So here is one that's a little bit more to it. Y equals x to the third power plus 2x minus 2x squared minus 14x plus 10. Is that one still a cubic function?
Yes.
Because the highest exponent is a
3.
3. Now remember, the easiest one is just y equals x to the third power. I just added a whole lot more terms to it, but it's still considered a cubic function because the highest exponent is a 3. It's still going to have some ups and it's still going to have peaks and valleys. Okay? Questions? Alrighty. It tells you something else about that one as well. For this particular one, the turning points, look at how many turning points it says it actually can have. For bullet number 4, how many turning points can it have? It gave me 2 numbers. What's the first number? 0 or 2. So you either got none or 2. So it's saying that this might not always look like this. It could look like something like this. And I'm just putting it up here. You don't have to draw this. This actually, x to the third power, depending on the equation, could look something like this. Do you see a curve?
No.
You can't even see a peak in a valley. It could look like that. That's what they mean when they say it could have no turning points. You got it? Okay. So it's either 0 or 2 for the turning points. So now it wants us to make sure we understand. Usually it's going to look like these two that you see here. And when it does, the curve opens up on the right if the leading coefficient is positive. Was this x cubed, was it a positive x to the third power? Yes. So it says that this one is going to open to the ceiling, opens up on the what? This one opens up on the right, opens to the ceiling on the right side of the curve, opens to the floor.
On the left.
On the left. So opens up on the right, that should say up, and opens what? Down on the left. Got it? When does it happen like that? It's cubic, and when it's what? Positive in the front. This is a positive. No number there, which means it's positive. When does it open the other directions? When it's negative in the front. So look at what happened with this one. So here, it opens up on the left and down on the right. Okay?
I was going to the, not right, to
Which one?
the y equals x4.
Okay, so we're gonna go to that one next. Let me make sure I got everything. Yep, I got everything. So the next slide is for the quartic function. So let's do the quartic function. It's a quartic function because it's the highest exponent is a 4. The basic one or the easiest one you can see is the one we put up here, y equals x to the 4th power. How many turning points can it have?
3.
Or 1. So it could have 1 or 3. So most of the times they're going to look like this. But is it possible that it looks something like, and I'm writing this where you can't even see that there's a dip there. Is it possible that it looks like that? Yes. So the only thing you see is this bottom because there's not enough of a curve here for you to call it a turning point. You understand what I'm saying? So because there's not enough of a curve for you to call that a true turning point, it only has one turning point. That's right here. Just the turning point is right there. So how many turning points can a quartic function have? 1 or 3. Okay. All righty. Look at what it says. If it's positive in the front of x to the 4th, both ends go open up. If it's negative in the front, both opens down. So that's all you're going to say. Both open up. And these both open down. All right, questions? All right, that is the end of 6.1. Let's jump to 6.2. There's nothing in 6.2 for you to do because all the homework requires you to do is actually put it in Zuru. So you're gonna learn how to get some data, paste the data in Zuru, and it'll create an equation for you. That's all of 6.2. That's it. So with that said, let me show you how to do this in Zuru, because I know that was a question that popped up, like, how are we supposed to do this in Zuru? All right, so let's go to Zuru. And let me show you, there's some data. You click on PR. See where I am? I'm in the polynomial. Click on PR. What other thing do we use PR for in the previous? Quadratic. What does this number down here have to be when it's a quadratic?
2.
A 2. But since we're doing cubic and quartic, we got to change them between 3 and 4. If it's cubic, change this to a 3. If it's quartic, change it to a 4. Hit calculate, and it pops up your equation on the bottom like you see. So for this one, this is the data that I put in. Look at the equation that I have. Now I only want 2 decimal places. Tell me what equation that you're going to have. If I only need 2 decimal places. Before you can round, what you got to do? So I got to move this over 1 place to the left. Okay. I want 2 decimal places. So negative what? Point.
0.
Okay. So you said negative 0 point what? 1/8. I only want 2 decimal places. 1/8 x to the 4. What's next? Plus what? 2/7. X to the 3rd. Minus what? 0 what? Okay. Okay, I need my x squared. Okay. Plus what? Point what? X minus what?
44.
It's going to round up to 44. Because those 9 nines are going to make that round to 44. So that's minus 44. That's the answer for that one. The only thing you had to do here was round.
Wait, so was this cubic or quartic?
This one is what? Tell it. What is this one? Why is it quartic? Highest degree is 4. And it asks you specifically for a quartic in the homework. It's going to say find the cubic or find the quartic function. And you just go pop your data, paste your data in here. Make sure that's a 3 or 4, whichever one it says. And then make sure you create your equation. Round to the right number of places, whatever it says. All right. That's the end of chapter 6. Did y'all see how easy chapter 6 was? That was it. That's all with chapter 6. That's it. So let's go to the study guide, please. I need you to see the problems from the study guide. I'm going to start from the bottom, or at least the second half, because it's got these types of problems, and I need you to see how to practice those. Yes?
Relation tool do you use for 5.4?
Exponential. Here is 5.4. Question was, it asked you for a power and exponential. You click on exponential, that EXPR. It's going to give you an answer with an E in it. You have to change it. Let me say this quickly so you'll know what I mean. When you put your data in, Zuru is going to say the answer is 3.91 e to the 2.3 x power. My math lab, even though this is right, mathematically this is a correct answer. It does not want to see this like that. My math lab wants you to change this to a number. So it wants you to put y is equal to 3.91. Now go put this in your calculator and tell me what you get.
So you put
e to the 2.3 in your calculator. What do you get? 9.97. So in the place of that, you're going to put 9.97 raised to the x power. That's what the homework wants you to do. This is right, but my math lab wants it written like this. Remember we said the formula is y equals a times b to the x power? It wants it written just like that, without the e in it. That's section 5.4. So if you're doing 5.4 and you're like, I keep getting the wrong answer and I know I'm typing it in Zuru right, it wants you to change e to the whatever it says. You got to change it and change it to a number, and make sure you keep up with how many decimal places it says, because it might say 2 places, it might say 1 place. Just keep up with it. This is 5.4, guys, if you're trying to figure out what I just wrote on the board. This is for section 5.4, if you're going back there to do that. Okay? And that's for exponential. This is just when it asks you for an exponential function. All righty. With that said, your study guide. Here is the study guide. All right, I'm going to start from the bottom and work my way up. I'm going to start from the middle. Not the bottom, but the middle. I'm going to start from the middle, which is here. I'm going to start at 14 and work my way down, and then I'll come back to the top. The top mostly wants you to do the circle method. But here, we're going to start here. All righty. For number 14, we talked about different ones. Which one of those is number 14? Is it the future value with the compounding periodically, continuously, or lump sum? Which one is 14? You got a 130 times e to the RT. It's continuous because it's got the e in it. If it's got the e in it, it's continuously compounding. What you thinking? Anytime it's continuous, it's going to have an e in it. It's continuously compounding. That means you got $130 for 6 years at 2% at the bank, and it's compounding continuously. How much money you going to have in 6 years? Put it in the calculator for me, please. All right, so here's what you should be putting in your calculator. Can I erase this part right here?
Yes,
All righty, so with that said, here is what we're saying. You've got y equals 130 times e raised to the RT, and R is 2%. How do I change 2% to a decimal? 0.02 times what?
6.
Times 6 years. That's what you should be putting in your calculator.
Right. So it's 146.
You should have your E button. You should be hitting your E button. So you type in your calculator. Somebody tell me what this is once you put it in the calculator. How much money you have in 6 years?
146.6.
Well, hey, I could have made that much extra money just by tutoring extra, rather than waiting 6 years to make that much money. Okay, what makes that not so much money? I mean, does the interest rate impact how much money you're going to get?
Yes.
Absolutely. 2% is nothing.
Yeah.
Okay, questions? So I need you to be able to put that in your calculator properly.
Yeah.
Questions?
So the 2% is 0.02
Mm-hmm.
times
6.
6.
Mhm.
That's what it is?
Mm-hmm.
Okay.
And you get 22.
Okay? We're okay? Number 15, go to Zuru. You got to type this in. The answer that's on here is not right. The answer you're going to get is going to be a different answer, but don't worry about that. Do this. I'll tell you what the actual answer, because it's not going to come up right like I want it from this screen. So go put it in Zuru for me, please. And it wants an exponential function. So where are you going to go in Zuru? EXPR. Type this data in for me, please.
PR, right?
PR.
Okay.
No. It says exponential. I'm saying it wrong. It says exponential. EX EXPR, yeah. Go type it there for me, please. Once you type it in, you should hit calculate, and it's gonna give you a whole bunch of stuff. Did you get it? Okay, what'd you get? Okay, so are you gonna do some rounding? Okay, tell me the equation, round it to 2 decimal places for me, please. I just wanna see what we're gonna get. If I got y equals, what, what did you say the number was?
2.656, so it would be.
2.65, what?
It would be 2.66.
Okay, 2.66, okay, we'll go with that. Times e to the
7.4, excuse me, 7.74.
okay, is there a 10 to the something power in that one?
Yes.
Aha, so that decimal should move where? Okay, it's gotta move over here, so this decimal's gotta go here. And there should be an X here, right? Okay. That's the equation. What does it want you to do now?
Give it a number.
Plug the 8 in. Where you get 8 from? Okay, so 2nd grade you read 9 books, 3rd grade you read 27 books, 4th grade you read 67 books, 5th grade you read 121 books. Y'all remember that? We want to know in 8th grade, how many books did you read? So plug in the number 8 in your calculator here. Those answers on the screen are not right, but you're going to get the right answer. In my math lab, they would have wanted you to convert this to a number, but I'm not having you do that for your part for the test here. So we plug in an 8. For this x here, put an 8, so that's going to be times 8. And what's the answer y'all got? 1,300. Actual 300.27. We're just going to round it to the nearest whole book. You could read half a book, but it's okay. So is it 1,300? It rounds to 1,300? Okay. So that says in 8th grade you read 1,300 books. Y'all remember that too? You didn't read that many? Okay. So if with this exponential function, that's what we're predicting, that maybe in the future 8th graders will read 1,300 books. Your grandchildren will read 1,300. Okay.
The answers are wrong.
Those answers were out. The answer sheet says it's 1883, and it does it differently, but this is what I want you to do. It's exactly what you did is perfect. So scratch out the answer and just put 1,300, because that's what it's supposed to be. All right, we're good? Okay. Number 16 says find the exponential model, that exponential equation that models that data. Here is your data. Are you going to get something with an E in it? Yes, you are. And in this case, you're going to have to convert it because it wants it not without the E in it. All right, so tell me what you get once you put it in. 0. Once you get it, tell me what you, once you get it, calculate it, tell me what you get as your answer. Did everybody already sign in on the sign-in sheet while we're doing this?
Yes, ma'am.
Okay, everybody's good? Okay, so you got -2, comma 9, -1, comma 13.50, comma 20.251, comma 30.375, and what you got? All right, tell me what you got. Give me what you started, because you're not going to find the exact one yet till we modify it a little bit. So tell me what you got starting out with y equals,
We're still putting them in.
oh, you're still putting them in, okay.
4.25.
E to the what?
4.0546.
Okay, that's enough. Was it negative to the negative?
Yeah.
Okay, so my decimal gotta move over here. Alrighty? And that's time X right there. Now, there ain't no E in the answer. So what you gotta do? I need you to go put this in your calculator by itself and tell me what that is. Put that in the calculator by itself and tell me what E to the 0.40546, what is that?
1.5.
So this right here is yeah. Did you get 1.5?
Yes.
Question. What questions do you have? If it doesn't give it to you in the E format, you have to figure out what that is before you can give me your final answer. Alrighty, questions? Alrighty, that was 16. We're going to, whoops, page back up.
Question.
Yes.
Why on this one we just found just the E? I guess because it was in parentheses like the other one, is that this one?
You're saying why did we not do it in the last one?
Yeah.
Um,
And
be-
that's because it wasn't in parentheses, is that the difference?
in the last one, we weren't gonna get the right answer on the paper regardless.
Mhm.
And so I wanted to leave it in that format because it didn't ask you for the equation. You
Okay.
see what I'm saying? It didn't ask you to plug in anything. It just wanted to know exactly what the actual equation would be. This one didn't ask you for the equation. It just wanted you to plug something into the equation that you did get.
Okay.
But in this particular case, because it required you to put it in this format, we had to change it.
So we would have had to plug in something for the X. Then
Yes.
we would put that number in parentheses.
No, the only reason why I'm saying it's different is because for some reason, even when you plug numbers into this one, it works out okay. I don't know why that other problem doesn't work out okay. See, what I'm saying to you is that no matter if you plug the number right here or right here, you should get the same answer because these mean the same thing. This one, the other one doesn't work out regardless. That's why I wanted you to change it. Alrighty, so number 18, wait, I skipped 17. All right, number 17, find the amount of money in your account after 12 years if $4,100 is deposited at 6% annual interest compounded quarterly. Am I using the periodic compounding, continuous, or lump sum? Periodic compounding? Okay, so with that said, I'm going to be using over here this formula. All right, what you going to put in your calculator?
4,100.
Okay, so I'm gonna put, I need S is 4,100 times what?
Parentheses 1
Uh-huh.
plus.
What's the interest rate? 6%?
Yeah,
So it's
0.06.
0.06. How many times are we compounding it?
Annual,
How many times?
12 years.
quarterly.
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 Times.
4 times.
That's 4 times a year. All right, raise that to 4 times how many years is what? How many years did they say?
12.
12 years. Put that in your calculator. Somebody tell me what the answer is.
The answer is 837,826.
How did you determine that that was quarterly? It's gonna be 8.
Oh, from this list over here. So annually is once a year, semi-annually is twice a year, quarterly is 4 times a year, 12, so forth and so on. So when it pops up on a homework or a test, they're gonna use these words.
Okay. It's 837,826.
Yeah, 8376.
Okay? You gotta make sure you put this in your calculator right. So you end up with $8,378.26 after 12 years. You okay? All right, that was number 17. Number 18 says this. Find the exponential function that satisfies the given condition. Here's what we're expecting you to do for this. Do you remember we learned something about this raised to the t power? I showed you that the a, b, and b could be written with 1 minus the rate. If it's decreasing, that's a minus sign. If it says it's increasing, that's a plus sign.
So if it's decreasing, it's a plus sign? Could you repeat that?
Mm-hmm. You could rewrite, in the word problem, it will state whether it's a decreasing condition or if it's an increasing condition. If it's decreasing, it should be 1 minus whatever the rate is. If it's increasing, it should be 1 plus whatever the rate is.
Decreasing. Increasing.
This one would have come from section 1.4, it's not 1.5.4. Alrighty, so do they give you some information here? And I forgot to put my A here, guys. There's an A here. So there's an A here in the front. That's your initial value times whatever B is. Remember we talked about A, B, and K? This is A, this is B now, 1 minus whatever the rate is, raised to the number of years. Alrighty, so I'm just gonna fill it in. They just want the equation. I'm just gonna fill it in, so I need the equation. Alright, what's the initial value?
55.
Okay, 55. Is it increasing or decreasing?
Decreasing.
So it's 1 minus now. That's 0.46%. What do I change that to? 0.0046, because it's 0.46%, so 0.0046 raised to the t power. Can I leave this like this, or should I simplify 1 minus that? You should simplify it, okay. So when I do that in my calculator, what's 1 minus 0.0046? 0.9954 raised to the t power. Done. Questions?
So I'm putting 55 parentheses, right?
Yes?
1 minus 0.0046. Then parentheses again.
Yes.
Can I hit enter?
Well, they didn't ask us to plug anything in. They just wanted you to find the equation. They didn't ask us to plug anything in for anything. They just wanted you to write the equation. So that's the equation. You see what I mean? They didn't want you to plug anything in for t. They just wanted you to write the equation for it. So if you were plugging something in, you would have finished it, and we would have said, oh, t is 8 years, 6 years, 10 years, whatever t is. But since we didn't plug anything in, it just says, can you find the function, which means can you write the equation? That's all they wanted you to do for that one.
Okay, I must be stuck on that because when I put it in my calculator, I don't get that 0.9954.
Did you just, no, you don't put we're just doing this part right here.
I did that part.
Not the 55. You're just doing what's in, all I need you to do is simplify this part right here. You were putting the 55 in, right?
Oh, yes. So
Don't put the 55 in. The 55 is good. It needs to stay right where it is. I just need you to subtract 1.1 and, the 1 minus 0.0046.
okay.
You see what I meant?
Yeah. Okay.
But I still don't get that when I do that.
I get what you're trying to say.
All you just put in your calculator is 1 minus 0.0046, and you should get 0.9954.
You don't need to put parentheses, just put 1.
Oh, you should have a button that says, there should a button on your calculator that should say S to D. Do you have one?
Oh,
If you have an S to D button, it'll turn it from a fraction to a decimal. Did it give you the right number?
Let me do it again.
Okay.
So you don't have to worry about the initial value, they just want, I got that.
We're okay?
Yeah.
Okay. Maurice, did it work?
'Cause I just fixed that.
Okay. Yeah, if you ever get something, you got a fraction and you need it to turn to a decimal, you should have an S to D button on your calculator. It literally is S with an arrow to the D, and it changes it from fraction to decimal. Alrighty, so number 19. Number 19 just wants you to plug the numbers in and put them in your calculator.
Right, it's the same as number 17,
All right, you have how much money?
$1,000.
Have $1,000 invested for how much interest rate? 5%? Compounded how often? Semi-annually, which is twice a year. Put the numbers in the place of RK. What's N? N is the number of years. Instead of calling it T, they called it N. That's the number of years. Type this in your calculator just like you see it. Somebody tell me what the answer is once you got it.
14,1297.
Y'all all get the same thing? You got what? Did you put it in there right? Do you have the fraction button on your calculator? Well, you don't need it. You do, but you don't really need it for this one. So when you type this one in, you actually put in 1,000 parentheses 1 plus, what was mine? 0.05 divided by 2 raised to the n times k power, which is 14. So did you do that? Did you type it that way? Number 20 is the same kind of way.
I got it now.
You got it? What did you put in there different?
I put it, it's with the K is in it, I put it 0.05.
Gotcha.
Instead of
Okay.
putting 2.
Gotcha. So all I'm saying is this is a very calculator heavy test. So you need to make sure you put it in your calculator right. Okay, number 20, same kind of problem. How many times are we going to compound this stuff? Monthly. So how many times a year is that? 12. All right, so here's my equation. I'm starting out with how much money? How much money I'm putting in this investment? $2,800. 1 plus, what's my interest rate?
7%.
7% divided by 12 raised to the 12 times 5 years, which is 60. There you go. That's what goes in your calculator. Alrighty, that was, what answer is number 20?
39, 69, 35.
I heard 2 different answers. What you get for number 20? I heard 2 different answers. 39, 69,
35.
but then the other answer is 39, 27, 14.
Yeah, but it's B, like he's, 39.
Did you say, B?
Said B.
Okay, I thought you said, okay, gotcha. So we all right. I thought you said D as in David. Okay, all right, that was good. Number 21. Felipe has a saving account that has a balance of $22.38 in it, $2,238. After 3 years, what will the amount of interest be at 6% compounded quarterly? Now, do I want to know how much money he has in his account, or do I want to know how much interest he earned? I want to know how much interest. So, am I still going to plug this into that formula? Yes. Then what?
Subtract it.
Then I got to subtract how much money he going to have from the original amount of money that he had, so I can figure out how much interest he earned on his money. So, you end up still with 2238 times 1 plus my interest rate is 6%. That's 0.06 compounded quarterly, which is 4, and then I got 4 times 3 years, which is 12. Put that in your calculator. Whatever answer you get, subtract 2238 from it. What you get?
437.79.
What did you get? Well, you didn't tell me what did you get? How much money was it?
2,675.73.
Okay, 2,675.73. Okay, and then I'm gonna subtract 2238 from that, and you said I get how much for? For what?
437.39. I mean 79.
Okay, we're good? All right, that was 21. 22, determine whether the polynomial is cubic or quartic. Look at the pictures, you got pictures on the board, cubic or quartic, it is quartic. How many turning points do you see? 3, okay. All righty. Number 23, you have an equation, bottom of the screen. It says state the degree and the leading coefficient. The leading coefficient always sits in front of whatever has the highest degree. What's the degree? 4. What's the leading coefficient? 16. Now, could they have written that equation in a different order? Yeah. Should you expect it to be in a different order? Yes. So I could have put the 5 first, and then the minus 5x, and then the 16x to the 4th power. So don't get tripped up because it's not in the right order. So if I give you an equation that looks like 3 plus 2x minus 4x squared, 4x cubed, plus 9x squared minus 15x to the 4th power. What's the degree of that equation?
4.
What's the leading coefficient?
15.
Negative 15. So don't assume that it's going to be in the right order. Always look for the highest exponent, and the number that sits in front of that is always your leading coefficient. Alrighty. So what's the answer for this one again? Okay, degree is 4 and the leading coefficient is 16. Alrighty, next one. Predict the end behavior. This means it's going to open up or down, one up, one down. Which way is this one going to open? Okay, where's my curve at? You see it? Is it cubic? Yes. Does it have a negative in the front? Yes. So which is going to open up on the left and down on the right? Got a negative in the front. Questions? Number 25, it wants you to go put this data where?
In Zuru.
And when you put the data in Zuru, where am I going to put it in Zuru at?
PR.
Under PR. And then what must I do when I get to PR?
Change the degree.
Change the degree to what? Change the degree to what?
4.
4. Why?
Because it's quartic.
Because it asks for a quartic function. So once you do that, you're going to get an equation that looks like one of the ones you saw on the board here, which I actually did this one at the beginning of the class. So here is that one that I showed you. Did I keep it? I did keep it. There's the equation. See at the bottom of the screen? Remember we rounded, this was the first one we did. Remember this was, I had to move my decimal one place to the left.
Yes.
I wrote this one on the board already, then I erased it, so it's negative 0.18.
Raise.
the x to the fourth, 3.27 minus 20.02, x to the second, 51.93 minus 44. Did you see that? I just typed it in. Make sure my degree here is 4. Make sure it says degree 4 because it asks for a quartic. There's my data. Your goal is to make sure you round it properly. So see the equation at the top of the screen? I rounded it at the very top of the whiteboard. Up here. I thought I erased it, but I guess I didn't. It's minus the 44. Once you round it, this was minus, where's my black one? Minus 44 should be at the end. Minus 44. So that's how it should be rounded. Questions? Alrighty? The next one wants you to do what? Same thing, only this time what you gonna change your degree to? Change your degree to a 3 and pick the right equation. Oops.
Sarah, what is going on with mine? It keeps on changing my degree to 3, even though I put it at 4.
Yours keeps changing it?
Yeah.
Now here's one, what I would recommend, open up a whole new window. Don't even try to put them, if you're trying to do 2 different ones, put the quartic in one window, open up you a new window and do the 3rd degree, just so you don't get them, if you're trying to keep it as 1 degree and it keeps flip-flopping, try it and see if it does it if you keep the degree in 2 separate ones. Alrighty. When is y'all's test again? Thursday. Thursday.
And, you said after 31, after, oh no, that's the day that we're gonna study 45.
Hold on, let me finish this and then we'll talk about, see what it, all right, so that was number 26. So we just did 26, number 27, that's the last one on this side. I know it's time for most of y'all to go, but I want to finish number 27. Number 27 says don't use your calculator. Now, there's not one on the test that you're required that you can't use your calculator. So I'm going to show you how to do it with the calculator and without the calculator. So if you do it with the calculator, if you have the button, remember we're talking about having the button?
Yes.
If you have the button, can you just put it in your calculator?
Yes.
Yes, you can. If you don't have the button, how you got to type it in your calculator? Log 32 over log 8. If you don't have a button, you got to type that in your calculator. And the answer you should get the answer screen. Here is how they wanted you to do it since it said no calculator. You ready? It wanted you to rewrite. This was not intuitive because I had to think about it for about 3 minutes before I figured out what I was supposed to do. This wants you to rewrite 32 as 2 to the 5th power. Because it's 2 times 2 times 2 times 2 times 2 is 32. And then it wanted you to write log base 8. It wanted you to write 8 as 2 to the 3rd power, because that's 2 times 2 times 2. You okay? And then it wanted you to remember there are some properties that we learned where we said multiplication turns to, multiplication turns to addition, and division turns to exponents get pulled to the front. Does it have an exponent in it? So the exponent gets pulled to the front, and the exponent down here on the bottom gets pulled to the front. What can I do with these 2 things? Done.
That, you know, what I did.
That's 5 over 3 is the answer. That wasn't so intuitive. Even I had to think about it for a second before I did it.
I couldn't figure it out. So what I did to myself, I said, okay, there's no number that 8 will not go into 32, but
Correct.
they both went into 2.
Correct.
And so I just figured out how many times each one of them went into 2.
That's the idea that they were hoping that we would figure out. Like I said, it took me a couple minutes for me to decide how I was going to work that out, but that was what they were hoping you were going to do.
But
But there won't be one that you're required not to use the calculator on the test. Okay? All right, let me go back and do, there's specific ones that I want to make sure I get back to. Number 12, I want to use those properties and do number 12. Here's number 12. All right, number 12 says you've got log base 2 of x to the 8 times y to the 7th over 5. We're going to use those properties. Multiplication turns to addition.
Right.
Division turns to subtraction. Exponents get pulled out front. So I'm going to put a time sign here so you know that's multiplication. All righty? So multiplied turns to,
Addition.
so we're going to write log base 2 of x to the 8 plus log base 2 of y to the 7th. You okay so far? What did I just do?
You added.
Turn multiplication to addition. Alrighty. The division sign. What does division turn to?
Subtraction.
There's my subtraction sign. So I got to do subtract log base 2 of 5.
And move forward.
Alrighty.
Yes.
Is that the final answer that we want?
No.
Can't leave. Did you notice it says you can't leave it with any exponents? It says without exponents. You cannot have any exponents in your answer. Do you still have exponents in your answer?
Yes.
What does the property say we're supposed to do with exponents?
Pull them to the.
Pull them to the front. So the final answer should be this 8 goes here. And the 7 goes where?
In front of.
In the front. Now do you have an answer that looks like one of these?
Yes.
Yes. Done. So just remember, these numbers get pulled to the front.
Can you say the same one more time?
Say it again.
Can you say the same one more time?
Okay, so multiplication becomes addition. Division becomes subtraction. Exponents get pulled to the front.
Except for the last one.
Ain't no exponent on the last one.
That's division is under.
What you mean when you say last one? Which one?
I can hardly see that. It's the
Log
bottom.
base 2 of 5?
Yeah.
There was no exponent. I ain't got nothing to pull to the front.
Oh, okay.
So you ain't got no exponents, you can't do anything. So I had to leave that part just like it was.
Got it.
You okay? Number 13. So I think I started with 14. Yeah, I did. Let's look at 13. If it has if it's in exponential form, you got to use the circle method to solve it. If it's in log form, you got to use the circle method to solve it. So any of these where you're solving, you're going to have to use the circle method, whether it's in log form or exponential form. So here is 13. 20 raised to the x power equals 54. Do the circle method. Dot here, arrow to 54, and another arrow back to x. Log, what goes in the first box?
20.
Second box. Last box. Put this in your calculator, that's your answer. Now, if you don't have the button, what do you have to put in your calculator? If you don't have the button, log what? Over log 20, and then you should be able to get your answer. Got it? Okay. Alrighty, let's start. I'll work my way backwards now. You got it? Let me see. Okay, so how your factor is in here. Do you have a fraction button? I don't see a fraction button, so you're gonna have to clear
you type in log, so get to your log 54. And now, you're gonna have to put a parentheses around this whole thing. Go ahead and do a close parentheses. Parentheses in front and back. Put a parentheses, you have to remember all this other stuff. Don't do that. Just 54 back in there, okay, close parentheses, and a second, because you want all of that on your top. Now last, now division sign. Okay, yeah, there you go, divided by, now divided by log 20.
Here's what some of you all, depending on how your calculator is, you have to put parentheses around this top part. Otherwise, it doesn't calculate it right. Some of you gotta put parentheses around this part. If you don't have a fraction button, it's most important that you put parentheses around. If you don't have the button, unless you break it up into fractions. Because otherwise, it doesn't calculate it properly.
So what's the answer?
1.33? Okay, number 11. Number 11 says log base 5 of x is equal to -3. Do the circle method. Anytime you solve for x, do the circle method. So here to here. What goes in the first box? Second box. Equals x. Now, I don't see neither one of that. That's not up there. How did they write this answer? As a fraction. Can you turn this into a fraction? Yes, it's going to be 1 over 5 to the third power. And what's 5 to the third power? 125. It wanted you to rewrite it as a fraction. When there's an exponent that's negative, it's always going to turn it into a fraction with the exponent on the bottom. Number 10, if you have the button, you can just type it in there just like that. If you don't have the button, you have to type in log 16.58 divided by log 6, and you'll get the same answer. You got it? Y'all working on the calculator?
Yeah,
Okay.
our calculators are kind of similar, so.
Okay. Got it?
But it's pretty much the same one though.
Okay. Alrighty, so we just did number 10. So you saw number 10. If you had a button, you can type it just like it is. If you don't, you gotta put it in here like this one.
Yeah, we finally figured it out. 1.56.
What'd you get for the answer for that one? 1.567.
Now, what is the button? I guess I don't have the button.
You don't have the button. Your button should have something like, it should let you be able to change. Some of you got a button that's like this.
Oh, no, I don't have that button.
No, me either.
Neither, all this money and we don't got the plan.
And we have the same one, right?
Okay. Number 9, there's no work to number 9. What's the answer?
Just 2x.
2x. Remember, when the 6 and the 6 are the same, the answer is the other number. That was one of your properties. When this number, when this and this are the same, the answer is whatever that is. So the answer is 2x. There was no work for that problem. It's a property they're just assuming we're going to remember. Number 8 wants us to find the inverse. Alrighty, here is the function is f of x is equal to 5 to the x power. Step 1, replace f of x with a y. Step 2, switch x and y around. Step 3, do the circle method and rewrite it in log form. So it's going to be log, there should be a dot here, base 5 of x is equal to y. So the answer is this. Where is this at? That's the answer. Number 7 says find log of 6. It wants you to use the log of 2 and the log of 3. So that means the only numbers you got are 2 and 3. What you know about 2 and 3?
Don't you just add them together?
You do, but why? Because what? Can I rewrite this as 2 times 3?
Equals 6.
Oh, yeah.
Okay, and multiplication turns 2? That's why you could add them together. So that's log of 2 plus log of 3,
Oh,
which means add them together, and when you add them together, what do you have? You got
point
0, and that's 0.4771, and when you add them together, you get what? 0.7781. That was why you could add them.
Oh, okay, this is what I, so therefore, if it had a different number.
Okay, let's do a different number. What if it had said the log of 18?
Okay. So,
Let's talk about that, because that's important to know. What if it had said, what's the log of 18?
what number is that? 18.
Well, what times what equals 18? You can only use 2 and 3.
Oh, you can only use.
Can't use 9 times 2, because 9 ain't up there, so you can't use 9. Well,
So
do you
two-
know what times what is equal to 2? Can I first start out with a 9, just so you know that it had a 9 in it? Now, can I rewrite 9?
Oh, so log 2.
Can I rewrite this 9? What times what equals 9?
3 times 3.
So 3 times 3. There we go. Now I can only use the 2s and the 3s. I rewrote this 9 as 3 times 3.
So therefore,
So now it's gonna be log of 2 plus log of 3 plus
Plus 3.
log of 3. Now still add those 3 numbers together.
so you're adding 3 numbers together.
Correct.
And so when you, okay, so when you have to break it down more than, when you have.
You could have had 5 numbers multiplied. You still would have ended up adding.
Right, adding all of these factors that you got to make,
As long as it equals 18.
Correct.
to make 18.
Correct.
Right?
But you can only use 2 and 3s.
Right.
Right. Can't use
The
9.
formula.
Yes.
Right.
Because of the formula. Yes.
Right. And if it said 2 and 9, then.
If they had given you the 9, you could have done the 2 and the 9. But they only gave you 2s and 3s, so you could only use the 2 and the 3. All right, questions? All righty, so number 6, you literally type it in Desmos and pick the right picture. Number 6, type it in Desmos and pick the right picture. Yep. Number 6, you just type it in Desmos and pick the right picture, and the picture should be D. Alrighty, number 5, put it in your calculator. Everybody got the button. Just log 2.81, put it in your calculator. What you got? Done. All right, number,
So if, when I'm gonna get the log, it still want me to put something at the bottom?
10. Well, is it requiring it? It is requiring it. When there's no number, you put 10 because it defaults to 10.
Okay.
Number 4, write it in log form. Do the circle method. 10 to the 3rd power equals 1,000. Put a dot here. Draw your arrows in your circle. So first box is going to have what?
10.
10. Second box.
1,000.
Third box.
3.
Done. Number 3 is the same way. We're going to do the circle method. So we got 6 to the 3rd power equals 216. Do your circle. So I end up log what's going in the first box,
6.
second box,
216.
last box,
3.
done. and the first two, want you to turn them from exponential to logs. We just went from logs to exponentials. Now we gotta turn these from from logs to exponentials. So for this one, we've got log base 3 of 9 equals 2. Using your circle method, put a dot under 3, draw your arrow to 2, then to 9. What goes in the first box?
3,
Then a second box.
2,
Last box.
9.
Done. And then, the number 2, log of log base W of Q equals 19. Put a dot under the W, draw your arrow to 19, around to the Q. What goes in the first box?
W,
W in the first box, second box,
19,
raised to the 19th power equals,
Q.
done. All right, that's the whole study guide. And it is recorded, so I'm getting ready to publish it as soon as I get back. I'll put it online as soon as I get back, so you can go back and hear it as well.
Well, I did it, but I need to see if I sent the right one.
Hold on, let me stop the video.